Lesson 9F, Conservation of Energy. No energy is lost or gained by the system. The sum of energies before the event equals the sum of energies after the event. That means the sum of work in plus the initial kinetic energy plus the initial potential energy must equal the sum of work out plus final kinetic energy plus final potential energy. A closed system is one where no energy nor matter is gained by a system by its environment. It is one where no energy nor matter is lost by the system either into the environment. For mechanical energy, that means all energy simply transformed from kinetic to potential and back again, and not into other sources such as light, heat, or sound that may escape the system. It also means that the system is insulated from receiving these types of energy from their environment, such as light, heat, and sound. Perpetual motion machines are an example of a closed system, where the system runs indefinitely by conserving all of its energy, not losing or gaining energy into its environment. Mechanical energy is conserved in a closed system, meaning the sum of all potential and kinetic energies before an event will be equal to the sum of all potential and kinetic energies after an event. No mechanical energy will be lost or gained. It will remain at a constant. An open system, on the other hand, is a system where energy or matter enters into the system from its environment, or is lost from the system into the environment. The Earth is an example of this, where the sun's light and heat enters into the atmosphere and warms it up. The Earth's atmosphere in turn allows for the energy to radiate out into space. For mechanical energy, some energy is transformed into other types other than potential kinetic energy, such as light, heat, or sound. These other types of energies may be released into the environment, and as a result, the sum total of mechanical energy declines. The sum of mechanical energy initial does not equal the sum of mechanical energy final. In a mechanical system, it could mean work was done to the system initially, such as lifting a ball to the top of a ramp or pushing a pendulum to initiate its swing. Or it could mean that some of the mechanical energy was transformed into other types of energy, like the light, heat, and sound, which escaped the system during the event, such as the puck coming to a stop or sliding on ice due to friction. An example of a closed system is a frictionless pendulum, possibly in a vacuum. Once the pendulum begins to swing, there is no loss of energy as the mechanical energy transforms back and forth from kinetic to potential and back again. This can be seen as the pendulum returns to the same height each time. An example of an open system would be a pendulum on an earth exposed to friction. As the pendulum swings, it is obvious that the energy is escaping from the pendulum as it swings lower and lower. Some of the mechanical energy is transforming into heat energy due to friction. It is not simply transforming from kinetic to potential at 100% efficiency. Another example of a closed system would be the skateboarder riding up and down a half-pipe. Notice how the boarder returns to the same height each time. 100% of the mechanical energy is being transformed from kinetic into the potential and back again. In real life, the boarder would be in an open system and would not experience a perfect transformation of the mechanical energy from kinetic to potential and back again. Some of the energy would be transformed into heat energy due to the friction of the wheels on the ground, bearings in the wheels, and air resistance. As a result, the sum of kinetic and potential energy decreases, and the rider never returns to his initial height. A third example of a closed system would be an ideal bouncy ball. 100% of the ball's energy would be conserved, transforming from kinetic to potential and so on, with no other energies being generated. As a result, the ball returns to the same height each bounce. However, there is no such thing as an ideal bouncy ball, as a bouncing ball will transform some of its mechanical energy into heat and sound. As a result, the ball will bounce lower and lower each time.